Hello, class. This is Mr. Hart, and in this podcast, I want to go over the third part of the weather chapter, which is also my favorite part, which is on storms. Okay. And storms are quite interesting and fascinating, and this section is actually quite big, so we're probably going to spread it over two podcasts. But let's get right into it. The first and probably the most common storm that we'll talk about is a thunderstorm. So you've probably been in a thunderstorm and you heard the large sounds and the thunder roaring. You've seen the lightning strike and come down from the sky, right? Everyone's associated with thunderstorms. They happen all the time. Okay, there's a couple thousand all over the world every year. Okay, and so thunderstorms are quite beautiful and terrifying at the same time. But you may have not really thought about why a thunderstorm happens. Okay, so we're going to look at what's happening when a lightning bolt actually strikes. Okay, and so this is how I like to think about it. In a thundercloud, you have a large amount of electrons, right? Um, if you know what lightning is, you know it's associated with electricity, and electricity is associated with electrons. And when we see this lightning bolt, it's actually electrons moving. So we have this large buildup of electrons in a thundercloud, and we don't have as many down here. Okay, we have less buildup. Okay, in other words, the thundercloud is very negatively charged, and the ground is not. And so we have this large buildup and empty space basically for these electrons to move. And so when you get this large buildup, the electrons have enough energy to kind of flow to the ground. Okay, they don't like being bunched together like this, and so they'll naturally take a path through the air and come to the ground. Okay, and when that happens, that's what you see as this lightning strike. Okay, so a lightning bolt is literally electrons flowing through the air trying to get to the ground. Okay, and so if you get large buildup, okay, you get lots of electrons going through, which makes much brighter flashes like this one you see on your screen. Okay, right here. If you only have a couple going through, you might get a much fainter one like one of these ones over here. Okay, but any lightning bolt you see is actual electrons moving, and they heat up the air as they go through, which causes this burst, this flash. Okay, and so that is what causes a lightning strike. Okay, buildup of electrons in a cloud. Okay, and so any lightning bolt is going to be some type of differences in electrons. You can think of it as like if you put a bunch of people in a crowded room and then you opened up a doorway to a less crowded room, the people will naturally flow to the area that's less crowded, okay, because they don't like being together. Same things with electrons, they're going to get to a less crowded area, okay? And so we watched a video in class of a lightning strike in slow motion at this link. I highly recommend it. It's really cool to see. You can kind of visualize the electrons literally going down to the ground, trying to find an area where it's not so crowded, basically. And so go ahead and watch this YouTube link. It's really cool to see a lightning strike in slow motion. Okay? But hopefully you understand what lightning is, and hopefully you know a couple of lightning safety tips. Okay, a couple of things I always tell people is obviously stay away from metal, okay, or anything like that. It makes sense, obviously, that things that are good conductors like metal will be easier to be struck by lightning. Stay away from isolated areas like trees that are by themselves, things that are high from the ground. They are, good targets for lightning basically because they are higher to the ground. They're going to be the first thing that gets struck. Um, Usually, staying inside your house is a good bet in a lightning storm. Actually, staying in your car is very safe during a lightning storm too because your car is made of metal. And so, if a lightning bolt does strike your car, the lightning will actually go around the outside of your car and not through it. So, lightning, or if you're in your car, stay in your car. It's actually safe to stay in your car in a lightning storm or in your house. Also, they say to unplug any electronics to avoid any type of electrical surge. Okay, but hopefully you are familiar with those safety tips. But those are just some of my tips for if you are in a lightning storm or a thunderstorm. Okay, all right, and then lightning. Let's talk about why we get a bunch of electrons build up in a thunderstorm. So if you remember from a cumulus cloud, it's this towering cloud that comes up in the sky. Thunderstorms usually start as some type of form of a cumulonimbus cloud. Okay, and so air rushes up, we get a lot of moisture, and it fills the cumulonimbus cloud, as you can kind of see here. It starts to build the tower. And again, these things are very tall, almost 6 kilometers tall. Okay, but as you get the circulation going through these nimbus clouds, okay, you can kind of imagine it like the same thing as if you rub your socks on the floor and you touch your door knob. If you've ever done that, you get that little shock, that little lightning bolt. Okay, same thing as your feet move along the floor, they take electrons. Well, you can kind of think of the same thing here of as the air gets pushed up into the cloud, we also get a lot of circulation. So you can also get a large buildup of electrons. Okay, it's not the exact same thing, but it's a good analogy. Okay, so as we get the circulation in the nimbus cloud, we get this buildup of electrons. And again, the nimbus clouds can also have rain. So as they have the rain, they also can bring thunder if they get this large buildup of electrons. Okay, and as we have lots of thunderstorms, a good thing to keep in mind is that thunderstorms can spread over very large areas. So this map kind of shows a thunderstorm region. And so if you can see, the blue areas are just kind of the general clouds of the storm where there's not as much rain, okay, very low rain amount. But these red areas are the main thunderstorm areas, very stormy, very wet, large amounts of thunder, but they all come from the same general cloud structure. Okay, so one cloud structure can bring a whole bunch of thunderstorms. These little purple dots are actually thunder strikes, or lightning strikes, I mean, that have struck the ground. So this whole area can have thunderstorms, which is why they're so common to have thunderstorms, because they spread over such large areas. You can have these kind of isolated pockets of lightning and thunder that are occurring all at the same time. Okay. Then the last thing I want to talk about is I want to debunk a myth of that some people say lightning never strikes the same place twice. Well, that is definitely not true. Okay. Lightning can definitely strike the same place twice, especially if you're a tall building like the Eiffel Tower, isolated by yourself, made out of metal. Okay. I think the Eiffel Tower gets struck like 100 times per lightning storm, and something like a few thousand times a year. I don't know the exact numbers, but it definitely is getting struck more than twice. So don't assume just because lightning struck one area that it's safe. Okay, lightning can definitely strike the same place twice. All right, so let's move on. Let's go to tornadoes. Okay, so tornadoes are the next storm that we're going to cover. Hopefully you never have to worry about tornadoes in an area like Utah. We don't get them very often, but they are a very powerful storm that we should know about and understand. Okay, I've actually seen a tornado form once when I was driving, which was pretty cool. Okay, but let's talk about how tornadoes form and what they are. So you remember from a while back I said that wind will always go from a high pressure to a low pressure. Okay. So this is also the case with tornadoes. So they're kind of like this isolated pocket. So if you imagine from an aerial view, we have a pocket of low pressure air and high pressure air around the outside. And so this high pressure air will push on this pocket of low pressure air, and as it pushes, it starts to rotate this air, okay, until we get a good movement, a good circulation, okay, and we get the tornado that is occurring from this low pocket of air in the middle and this rotation from the outside high pressure air, okay. And so the low pocket of air is known as the eye of the storm, or the center of the storm. You may have heard of that before. Okay, it's generally fairly mild compared to the rest of the storm, but this large rotation on the outside is what you probably recognize as the tornado. Okay, but again, any type of windstorm, no matter how big it is, always comes from this same idea that high pressure flows to low pressure. Okay. All right, so let's look at some time-lapse pictures. So this is kind of a time-lapse of a tornado coming to the ground. So it starts in the upper atmosphere, and as it slowly settles to the ground, it takes kind of the clouds with it, so it kind of makes this funnel-looking shape as it comes to the ground and starts causing this quick rotation. Okay, and so it always usually starts in the upper atmosphere and slowly settles to the lower atmosphere or into the ground, and that's when we have the full-blown tornado that we're used to seeing. Okay. All right. So we watched a quick video about tornadoes on National Geographic. I think it's called Tornadoes 101 if you want to search that. It's also very good to watch and makes a lot of sense about what tornadoes are and how they form. Okay, but let's look at what areas of the world are, or not the world, but what areas of the U.S. are most commonly hit by tornadoes. Okay, so like I said, Utah and the western United States don't get hit by tornadoes a lot because we have a lot of mountain ranges and things like that. We're near the coast, which prevents a lot of tornadoes. Okay, but the Midwest is definitely the place that gets struck the most by tornadoes. It's very flat. It has lots of trapped air, and there's nothing that's really stopping a tornado from moving where it wants to. Okay, so the Midwest is Tornado Valley is what it's called. Okay, so you can see from this scale that the white and yellow areas have seen less than 5 tornadoes over about a 30 to 40 year span. Okay, whereas the orange and reds have seen over 25 in about a 30-year span, and so they're averaging about 1 a year on average. Okay, so lots of strong tornadoes striking the Midwestern areas of the United States. And so if you've ever been there, you'll know there's actually lots of storm shelters and things like that. A lot of people are prepared for things like this. I went to the St. Louis Zoo once, and their bathrooms were actually storm shelters as well, which is kind of cool. Okay, but you'll see a lot of storm shelters in these areas because they get struck by tornadoes so frequently. Okay, and again, these are only the strong tornadoes. That doesn't even count all the smaller tornadoes. Okay, and so let's look at the tornado scale. Okay, so when they measure tornado strength, they use what's called the Fujita scale, and it's just a scale they made to help us determine how strong a tornado is or how much damage it will do. Okay, so it starts at 0 and goes to 6. So an F0 tornado would be very light damage, not very strong, only 40 miles per hour. Like you could probably stand in one of these and you maybe get pushed over or something like that, but you wouldn't die for sure. These are very light. A couple tree branches fall off, things like that. Nothing too much to worry about. And F1 is starting to get a little bit more moderate. Cars and autos start to get pushed aside, things like that. And so as you get further and further and further down, okay, you get stronger and stronger and stronger, okay? And so F0, F1, and F2 are kind of the lighter ones. We don't really think of tornadoes when we think of these three. These are more small scale, definitely not the kind you see in the movies type thing. Okay, so these ones are pretty weak. Okay. But these three, or these four down here, are where you start to get the strong tornadoes that you kind of see in the movies. Okay, when it starts to actually pick up objects and destroy houses and things like that. Okay, F3s and F4s are very common. F5s and F6s are almost never seen. They're very rare, but they are incredibly powerful. Okay, but you will see a lot of F3s and F4s. Okay, especially in the Midwest. And so that's the Fujita scale again. The first three are kind of the weaker ones. The last four are the very strong ones. And so any tornado you see will be given one of these numbers based on how much damage it can do. Okay? All right. So last thing I want to talk about is a couple of tornado safety tornado safety tips in case you ever live in an area that is known for tornadoes. Some of the things they say are to go downstairs in the basement if there's a tornado. You don't want to be on the upstairs level or anything like that. You don't want to stand near windows because the wind can break through them and launch debris and things like that. They also recommend, if you don't have a basement, to sit in a bathtub of some kind, lay in a bathtub, because bathtubs are pretty heavy and the wind will blow over them generally. And so that's some of the main recommendations. Obviously, stay inside during a tornado is a big one, and get as low as possible. So those are just a couple of tips, but that is all we will cover for this podcast, and we'll talk about more storms in the next one. But let me know if you have any questions, and thank you for watching.